This is a presentation on sets. A set is a collection or list of objects, quantities or numbers with specified properties. A set is a collection or list of objects, quantities or numbers with specified properties. A set is usually denoted by capital letters such as A, B, P, Q, X, and Y. The objects that makes up the set are called elements. The objects that makes up the set are called elements of the set by a description enclosed in braces. A set is usually denoted by capital letters such as A, B, P, Q, X, and Y as shown. The objects that makes up the set are called elements of the set by a description enclosed in braces as shown. Now, when we consider the set Q, the members of the set Q or the elements of the set Q are 2, 4, 6, 8, and 10. These are the members or the elements of the set Q. So the members of the set Q are called elements. So the elements of the set Q are 2, 4, 6, 8, and 10. Now, when we look at the set Q, we can see that 4 is a member of the set Q. That is, 4 is a member of the set Q. And in set operations, we write 4 belongs to Q. We write 4 belongs to Q, where this symbol is used to denote the clause belongs to, or is a member of, or is an element of. So because 4 is a member of the set Q, then we say that 4 belongs to Q, or 4 is an element of Q, or 4 is a member of Q. Now when we consider the same set Q, the elements are 2, 4, 6, 8, and 10. So we can see that 5 does not belong to Q. 5 does not belong to Q. So this symbol is used to denote the clause does not belongs to. Does not belongs to. So we can see that 5 does not belong to Q because 5 is not one of the elements of the set Q. So we say 5 does not belong to Q. Now let's look at some definitions. An odd number is a number which cannot be divided exactly by 2. An odd number is a number which cannot be divided exactly by 2. When we say an odd number is a number which cannot be divided exactly by 2, then we mean that when we divide an odd number by 2, there is a remainder. When we divide an odd number by 2, there is a remainder. Now these are examples of an odd number. We have -5, -3, -1, 1, 3, and 5. Now, these are the examples of an odd number. When we divide -5 by 2, the answer is -2.5. Because the answer is a decimal, it means that there is a remainder. When we divide -3 by 2, we have -1.5. That means there is a remainder. That makes -3 an odd number. -1 divided by 2 equals -0.5. The answer is a decimal. It means that -1 is an odd number. Similarly, 1 divided by 2 equals 0.5. 3 divided by 2 equals 1.5. And 5 divided by 2 equals 2.5. The answers are all decimals, meaning that when we divide the numbers by 2, there is always a remainder. And that's why they are odd numbers. So odd numbers cannot be divided by 2 exactly. Now, let's look at an even number. An even number is a number leaving no remainder when divided by 2. An even number is a number leaving no remainder when divided by 2. And these are examples of an even number. We have -6, -4, -2, 0, 2, 4, 6. These are examples of an even number. These are examples of an even number. Now, when we divide an even number by 2, it leaves no remainder. Take note, it leaves no remainder. Now, these are examples of an even number. We have -6, -4, -2, 0, 2, 4, and 6. When we divide minus 6 by 2, the answer is minus 3. The remainder is 0. That is why minus 6 is an even number. When we divide minus 4 by 2, the answer is minus 2. No remainder. When we divide minus 2 by 2, we have minus 1. When we divide 0 by 2, we have 0. 2 divided by 2 equals 1. 4 divided by 2 equals 2. And 6 divided by 2 equals 3. So when we divide even numbers by 2, it leaves no remainder. It leaves no remainder. And that is shown by the illustration we have here. Now let's look at factors of a number. Factors of a number. Factors of a number are elements that can divide a number leaving no remainder. Factors of a number are elements that can divide the number leaving no remainder. So when we consider the number 12, factors of the number 12 are 1, 2, 3, 4, 6, and 12. So these are numbers that can divide 12 leaving no remainder. That is when we divide 12 by these numbers. When we divide 12 by the factors of 12, it leaves no remainder. Let's look at the illustration. Now, the factors of the number 12 are 1, 2, 3, 4, 6, and 12. When we divide 12 by 1, the answer is 12. The remainder is 0. When we divide 12 by 2, the answer is 6. No remainder. When we divide 12 by 3, the answer is 4, leaving no remainder. When we divide 12 by 4, the answer is 3. 12 divided by 6 equals 2. And 12 divided by 12 equals 1. So when we divide the number 12 by the factors, we can see that we have whole numbers. It leaves no remainder. We have 12, we have 6, 4, 3, 2, and 1. So when we divide 12 by the factors of 12, it leaves no remainder. It leaves no remainder. Now let's look at a prime number. A prime number is any positive number that has two factors, itself and 1. A prime number is any positive number that has two factors, itself and 1. A prime number is any positive number that has two factors, itself and 1. Example of prime numbers are 2, 3, 5, 7, 11, 13, 17, etc. Now, considering these prime numbers, we can see that 2 is a prime number, even though it's an even number. 2 is also a prime number. Why? Because 2 has two factors, itself and 1. 3 has two factors, itself and 1. 5 has two factors, itself and 1. 7 has two factors, itself and 1. So prime number is a number that has two factors, itself and 1. Prime number is a number that has two factors, itself and 1. Now multiple of a number. Multiple of a number. Multiple of a number x refers to any number formed when x is multiplied by any integer. Example, multiples of 3 are 3, 6, 9, 12, 15, etc. So the multiples of 3 are 3, 6, 9, 12, 15, etc. Now when we multiply the number 3 by 1, we have 3. When we multiply the number 3 by 2, we have 6. When we multiply the number 3 by 3, we have 9. When we multiply the number 3 by 4, we have 12. And when we multiply the number 3 by 5, we have 15. So when we multiply the number 3 also by 6, we also have 18. Now the multiples of 3 are 3, 6, 9, 12, 15, etc. A set P is said to be a subset of the set Q if all the elements of P belongs to the set Q. I repeat, a set P is said to be a subset of the set Q if all the elements of P belongs to the set Q. The symbol, that is this symbol, is used to denote the phrase subset of. That is the symbol used to denote the phrase subset of. Subset of. Now, let's look at this example. Considering the set P, the elements are 2, 5, and 8. And considering also the set Q, the elements of the set Q are 1, 2, 3, 5, 7, and 8. Now we can see that the members of the set P can all be found in the set Q. That is 2, 5, 8 can all be found in the set Q. 2, 5, 8. So we can write that P is a subset of Q. Why is P a subset of Q? This is because all the members or all the elements of the set P can all be found in the set Q. That is 2, 5, 8 can be found in the set Q. 2, 5, 8. So we say P is a subset of Q. Now, with the set A equals 3, 6 and the set B equals 1, 4, 5, and 8, we can see that the element of the set A cannot be found in the element of the set B. I repeat, the element of the set A cannot be found in the set B. So we say that A is not a subset of B. A is not a subset of B. A is not a subset of B. And that is the symbol we use to denote it's not a subset. It's not a subset. The universal set. The universal set is the set of all objects under discussion. The universal set is the set of all objects under discussion. The universal set is the set of all objects under discussion. We use the symbol U to denote the universal set. Example, if U equals even numbers between 2 and 20, that means that the universal set will be 4, 6, 8, 10, 12, 14, 16, and 18. U equals even numbers between 2 and 20. Because they are even numbers between 2 and 20, it means that 2 and 20 themselves are not inclusive. And so it's between 2 and 20. So the universal set U equals 4, 6, 8, 10, 12, 14, 16, and 18. An empty set. A set which contains no element is called an empty or null set. A set which contains no element is called an empty or null set. It is usually denoted by, these are the symbols we use to denote an empty set or a null set. These are the symbols we use to denote an empty set or a null set. The complement of a set. The complement of a set. The complement of a set, say A, is defined as the set of all elements of the universal set U. The complement of a set, say A, is defined as a set of all elements of the universal set U, which are not elements of A. What do we mean by this? Let's look at this illustration so you understand what we mean by a complement of a set. Now, considering the set A, the elements are 1, 3, 5. If A is a subset of the universal set, U equals 1, 2, 3, 4, 5, 7. The elements of the set A are 1, 3, and 5. And the elements of the set A can all be found in the universal set. That is 1, 3, and 5. However, we can see that there are some elements that belong to the universal set U, but does not belong to A. And the elements are 2, 4, and 7. 2, 4, and 7. These are the elements that belong to the universal set U, but does not belong to the set A. So we say that the complement of A, written as A complement or A prime, is given by A complement equals 2, 4, 7. that is 2, 4, 7. These are elements that belong to the universal set U but does not belong to the set A. That is what we mean by the complement of A. That is what we mean by the complement of A. Now we look at operation on set. Operation on set. Operation on set. Intersection of sets. Intersection of sets. The intersection of two sets, A and B, is defined as a set of all elements that belongs to both A and B. The intersection of two sets, A and B, is defined as a set of all elements that belongs to both A and B. Now, example, when you consider these two sets, elements of the set A are 1, 2, 3, 4, 5, and 8. And the elements of the set B are 2, 4, 6, 8, and 10. Now we can see that there are particular elements which belongs to both the set A and the set B. And those elements are 2, 4, 8. Because 2, 4, 8 can be found among the elements of the set A, and 2, 4, 8 can also be found among the elements of the set B. So because 2, 4, 8 belongs to both the set A and the set B, then we say that A intersection B equals 2, 4, 8. That is elements that belongs to both A and B. Element that belongs to both the set A and the set B. That is what we mean by intersection of sets. Now we have union of sets. Union of sets. The union of two sets, A and B, is defined as the set of all elements. The union of two sets, A and B, is defined as the set of all elements that belongs to either A or B or both. That belongs to either A or B or both. That belongs to either A or B or both. Now let's look at the illustration. Considering this example, the elements of the set A are 1, 2, 3, and 4. And the elements of the set B are 2, 4, 6, and 8. Now when we say A union B, it means that we are to combine the elements of the set A and the elements of the set B. But take note, for union of sets, repetition is ignored. What do I mean by repetition is ignored? When we look at the element of the set A, we have an element 2. And that same element 2 can also be found in the set B. So when we are writing the union of A and B, we write only 1. We don't repeat the number 2. And the same thing applies to 4. So A union B equals 1, 2, 3, 4, 6, and 8. That is 1, 2, 3, 4, 6, and 8. 2 does not repeat itself in the union, and 4 also does not repeat itself in the union. Normally, it's done in ascending order. That is from the least to the highest. So with the union of sets, we only combine the two sets in ascending order from the least to the highest. But take note, repetition is ignored. Now let's look at some solved problems. Given the set A equals 2, 3, 4, 5, and 7. The elements of the set A are 2, 3, 4, 5, and 7. And the elements of the set B are 2, 3, 4, 7, 10, and 19. We are given the universal set, and these are the elements 2, 3, 4, 5, 7, 10, 13, 19, and 37. Now we have to list the elements of A complement intersection B. A complement intersection B or complement. Now let's look at the solution. From the question, we were given the set A and the set B and the universal set. And the elements of the set A are 2, 3, 4, 5, and 7. And the elements of the set B are 2, 3, 4, 7, 10, and 19. Elements of the set U are 2, 3, 4, 5, 7, 10, 13, 19, and 37. Please, when you are solving a problem, don't circle the answers as shown. Don't circle the element as shown. Don't circle the element as shown. This is to help you to understand how the problem is being solved. Now, we are asked to find A complement intersection B. A complement intersection B. Now, when we consider the elements of the set A, we have 2, 3, 4, 5, and 7. And this is the universal set. So A complement are elements that belongs to the universal set, but does not belong to the element of the set A. That is what we mean by A complement. Now, when we look at the element of the set A, we have 2, 3, 4, 5, and 7. And these are the elements that are circled in the universal set. 2, 3, 4, 5, and 7. However, there are some elements in U which cannot be found in A. And the elements are 10, 13, 19, and 37. And so A complement is equal to 10, 13, 19, and 37. These are the elements that can be found in the universal set, but cannot be found in the set A. That is what we mean by the complement of A. So A complement equals 10, 13, 19, and 37. Now you have to find A complement intersection B. A complement intersection B. A complement intersection B. Now we have A complement, and the set of A complement are, the elements are 10, 13, 19, and 37. And B has been given from the question, that is 2, 3, 4, 7, 10, and 19. So A complement intersection B means that we are to search for elements that belongs to A complement and also belongs to B. And we can see that the elements are 10 and 19 because 10, 19 belongs to the set B, and 10, 19 also belongs to the set A complement. And therefore A complement intersection B is equal to 10, 19. Now, we were given A in the question, we are also given B and the universal set. Now, A complement intersection B complement. From A complement intersection B give us 10, 19. 10, 19. So, A complement intersection B or complement means we are to search for elements that belongs to the universal set but does not belong to A complement intersection B, that is 10, 19. And when we look at the universal set, 10, 19 are elements that belongs to A complement intersection B. So all the other elements that does not belong to A complement intersection B are the members of the set A complement intersection B or complement. So we have 2, 3, 4, 5, 7, 13, and 37. And that is how come A complement intersection B complement is equal to 2, 3, 4, 5, 7, 13, and 37. That is elements that belong to the universal set U, but does not belong to A complement intersection B, that is 10, 19. And the elements are 2, 3, 4, 5, 7, 13, and 37. Now, let's consider a Venn diagram. Venn diagram. A Venn diagram is a diagram that shows all possible logical relations between a finite collection of different sets. Between a finite collection of different sets. Now we consider a two-set problem. Number of U is the universal set. Let's assume that this number of U represents the total number of students in a particular school or a particular class. And let the number of A represent the number of students who read Agric. And let number of B be the number of students who read biology. Now we have A, B, C, and D. That is, we have the region A, region B, region C, and region D. Now the region A is the shaded region. That is the region that represents the number of students who read only Agric. The number of students who read only Agric. Now, number of A is the number of students who read Agric. But the A itself, that is the shaded region, represents the number of students who read only agric. Only agric. Now, B is the region that represents the number of students who read both agric and biology. And C is the number of students who read only biology. And D is the number of students who read neither agric or biology. And take note that when you add A, B, C, and D together, it must be equal to the universal set. That's the number of students in the school or the class. But with the shaded region represents the number of students who read only agric. Only agric. Now, considering the shaded region, that is region B, it represents the number of students who read both agric and biology. The number of students who read both agric and biology. And with the shaded region C, this represents the number of students who read only biology. Who read only biology. Who read only biology. Number of B represents the number of students who read biology. But out of the number of students who read biology, there are some students who also read agric. So if you want to know the number of students who read only biology, then you have to subtract B from number of B, and that will give you C. Also, if you want to know the number of students who read only agric, then you have to subtract B, that's the number of students who read both, from the number of students who read agric, and that will give you the number of students who read only agric. Now, looking at the shaded region, that represents the number of students who read neither agric nor biology. Who read neither agric nor biology. That is outside the two circles. That is the region that represents the number of students who read neither of the two subjects. Who read neither of the two subjects. So don't forget, when you add all these four regions, that is A, B, C, and D, it must be equal to the number of students in the class. Now, let number of A be equal to the number of agric students. Let number of B be equal to the number of biology students, all in the same school. And the number of U equals the total number of students in the school. Now, number of A, that's the number of agric students. Number of B, number of biology students. And A represents the number of students who read only agric. B represents students who read both agric and biology. And C represents students who read only biology. And D represents students who read neither agric nor biology. Now, when we add A to B to C to D, the results should be equal to the total number of students in the school. So A plus B plus C plus D equals U. Take note, if each student read at least one of the subjects, then it means that the region D will be equal to 0. If each student read at least one of the two subjects, then it means that the region D will be equal to 0. In that case, when we add the three regions A, B, and C, it must be equal to U. That is situation whereby D is equal to 0. Now let's look at this problem. In a group of 50 traders, 30 sell Gary and 40 sell rice. Each trader sells at least one of the two items. This means that region D equals 0. This means that region D equals 0. Take note of this, because each trader sells at least one of the two items. Now I go over the question. In a group of 50 traders, 30 sell Gary and 40 sell rice. Each trader sells at least one of the two items. So how many traders sell both Gary and rice? How many traders sell both Gary and rice? Now, let U represent traders. G, Gary, sellers. If U represents traders, then it means that number of U equals 50, because from the question, the number of traders is 50. Let G represent Gary sellers. So the number of Gary sellers from the question equals 30. And the number of rice sellers is equal to 40 from the question. Let X be the number of traders selling both Gary and rice. That is the number of G intersection R is equal to X. Now let's go to the Venn diagram. Number of traders who sell Gary equals 30 from the question. And the number of traders who sell rice equals 40 from the question. And the number of students who sell both Gary and rice is represented by X. So if you want to know the number of students who sell only, the number of traders who sell only Gary, then you have to subtract X from 30. And that is how come we have 30 minus X. So 30 minus X is the number of students who sell, is the number of traders who sell only Gary. 30 minus X is the number of traders who sell only Gary. Now, if you want to know the number of students who sell only rice, that's the number of traders who sell only rice. I repeat, if you want to know the number of traders who sell only rice, then you have to subtract X from 40, and that is how come we have 40 minus X. So the number of traders who sell only rice is 40 minus X. The number of traders who sell both Gary and rice, the number of traders who sell both Gary and rice is X, and the number of traders who sell only Gary is 30 minus X. So 30 minus X is only Gary, X is both Gary and rice, and 40 minus X is only rice. Now the region D equals 0, because each trader sells at least one of the items. So the region D equals 0. The fourth region equals 0. So now when we add these three regions, 30 minus X to 40 minus X, the results should be equal to 50. And so from the Venn diagram, we add all the three regions. We have 30 minus X plus 40 minus X, and this is equal to 50. Now 30 plus 40 is equal to 70. Minus X plus X equals 0. But already we have minus X here. So we have 30 plus 40 minus X, and that will give us 70 minus X, and this is equal to 50. Now we are making X the subject. So minus X on the left hand side becomes X on the right hand side, and 50 on the right hand side becomes minus 50 on the left hand side. So we have 70 minus 50 equals X, and 70 minus 50 equals 20. So we have 20 equals X. Therefore the value of X equals 20. This means that 20 traders sell both Gary and rice. So assuming you were asked to find the number of traders who sell only Gary, and that will be 30 minus X. And so if you subtract 20 from 30, you get 10. If you want to know the number of traders who sell only rice, you subtract the 20 we have gotten from 40. And so 40 minus 20 will be 20. 40 minus 20 will be 20. But from the question, you were asked to find the number of students the number of traders who sell both Gary and rice. I repeat, from the question, we have to find the number of traders who sell both Gary and rice. The number of traders who sell both Gary and rice, and that is X, and X is equal to 20. Now let's consider the three-set problem. Let number of A be the number of Agric students, and number of B be the number of biology students, number of C be the number of chemistry students, all in the same school, and number of U equals total number of students in the school. Now when we consider the three-set problem, this is how the Venn diagram looks like. U is the universal set, that's the number of students in the school. Number of A, that's the number of Agric students. Number of B, number of biology students. Number of H, number of chemistry students. Now we have region A, B, C, D, E, F, G, and H. We have 8 regions. A represents students who read only Agric. B represents students who read only biology. C represents students who read only chemistry. Now D represents students who read only Agric and biology. Only Agric and biology. But when you add D to G, D plus G represents the region which represents students who read Agric and biology. Now E represents students who read only Agric and chemistry. But when you add E to G, it represents students who read Agric and chemistry. Now F represents students who read only biology and chemistry. But when you add F to G, it represents the region of students who read biology and chemistry. So A is only Agric, B is only biology, C is only chemistry, D is only Agric and biology, D is only Agric and chemistry, F is only biology and chemistry, and G represents the region. That's the number of students who read all the three subjects. That is Agric, biology, and chemistry. So take note that when we add all these 8 regions, it must be equal to the universal set. So A plus B plus C plus D plus E plus F plus G plus H is equal to U. Now let's look at this problem. There are 40 people in a class. 30 of them study biology, 22 study physics, and 21 study chemistry. 15 study physics and biology, 10 study physics and chemistry, and 13 study biology and chemistry. Now I go by the question. There are 40 people in a class. There are 40 people in a class. 30 of them study biology, 22 study physics, and 21 study chemistry. 15 study physics and biology, 10 study physics and chemistry, and 30 study biology and chemistry. Each student in the class study at least one of the 3 subjects. That means that the region 8 equals 0. The region 8 equals 0 because each student in the class study at least one of the 3 subjects. Now A, represent this information on a Venn diagram, and B, how many people study all 3 subjects? How many people study all 3 subjects? Now from the question, the number of students equals 40, so number of you equals 40. Number of biology students equals 30. Number of physics students equals 22. Number of chemistry students equals 21 from the question. Now number of students who study physics and biology equals 15. Number of students who study physics and chemistry equals 10. Number of students who study biology and chemistry equals 13. Now, when we come to the Venn diagram, we have region A, B, and C. Now from the question, number of students who study physics and chemistry was given the question to be 10. But if you want to know the number of students who study only physics and chemistry, then you have to subtract x from 10, and that is how come we have 10 minus x. Also, number of students who study physics and biology is 15. But if you want to know the number of students who study only physics and biology, then you have to subtract x from 15, and that's 15 minus x. Number of students who study chemistry and biology is 13 from the question. But if you want to know the number of students who study only chemistry and biology, then you have to subtract 13, x from 13, and that is how come we have 13 minus x. So we have region A, B, C, then we have 10 minus x, 15 minus x, 13 minus x, x, where x represents the number of students who read all 3 subjects, that is physics, chemistry, and biology. Now A represents students who read only physics. And if you want to find the number of students who read only physics, take note that when we add A to 10 minus x to 15 minus x, it must be equal to 22. It means that A plus 10 minus x plus x plus 15 minus x is equal to 22. Also, b plus 10 minus x plus 13 minus x equals 21. 15 minus x plus 13 minus x plus c is also equals 30. And so let's see how best we can find students who read only physics, only chemistry, only biology, and only chemistry. Now, physics only. A plus 10 minus x plus 15 minus x is equal to 22. Now, minus x plus x will give us 0. So we have a plus 10 plus 15 minus x equals 22. And 10 plus 15 equals 25. So we have a plus 25 minus x equals 22. And because we are making a the subject, x minus x on the left becomes x on the right hand side. Already we have 22 on the right, so we have plus 22. But plus 25 on the left becomes minus 25 on the right. And so a equals x minus 3. A equals x minus 3. That's the number of students who read only physics. Now, chemistry only. Here we also add the 4 regions in the circle. So we have b plus 10 minus x plus 30 minus x equals 21. And minus x plus x is 0. So 10 plus 13 will give us 23. So we have b plus 23 minus x equals 21. And plus 23 on the left becomes minus 23 on the right. So we have 21 minus 23, and that is minus 2. And minus x on the left also becomes x on the right. So we have b equals x minus 2. That means that the number of students who study only chemistry is x minus 2. So biology only, we have c plus 15 minus x plus 13 minus x equals 30. So minus x plus x is 0. Now we have 15 plus 13, and 15 plus 13 will give us 28. Already we have minus x here, and this is equal to minus 30. So we have c plus 28 minus x equals 30. And here we are also making c the subject. We are making c the subject. So c will be equal to x, that is minus x becomes x on the right hand side, and we have 30 on the right hand side, and plus 28 becomes minus 28 on the right hand side. So we have x plus 30 minus 28 is 2. That means that c will be equal to x plus 2. That means that c will be equal to x plus 2. So now we go to the Venn diagram again. Now after calculating for a, we have x minus 3. Calculating for b, we have x minus 2. And calculating for c, we have x plus 2. Now we have 1, 2, 3, 4, 5, 6, 7. We have 7 regions, because the region 8 equals 0. This is because each student studies at least one of the 3 subjects. That is why the 8th region equals 0. Now, when we add all these 7 regions, that is x minus 3, x minus 2, x plus 2, 10 minus x, 30 minus x, 15 minus x plus x, it must be equal to the universal set 40. And so, we add x minus 3 to x minus 2, we have plus x plus 2, plus 10 minus x, plus 30 minus x, plus 15 minus x, plus x equals 40. So we have x plus x plus x, and that will give us 3x. Then we also have minus x minus x minus x, and that will give us minus 3x. Already we have plus x, and that is our plus x. Now minus 3 minus 2 is minus 5. And minus 5 plus 2 is minus 3. Minus 3 plus 10 is 7. 7 plus 13 is 20. And 20 plus 15 is 35. And so we have 35 equals 40. So 3x minus 3x is 0. So we have x plus 35 equals 40. So x plus 35 equals 40. Because we are solving for x, plus 35 on the left becomes minus 35 on the right. And so 40 minus 35 is equal to 5. This means that the value of x equals 5. That's the number of people who study all 3 subjects is equal to x. And the answer is 5. This is the end of our presentation on sets.